Hello and welcome to another video. Today we got a board from a viewer. Dear Daniels, thanks again for agreeing to take a look at my Gigabyte Aorus Elite V2 board. I hope you don't mind, I used some unusual box filler to keep it safe during transport. I can't say much about this board, only that it doesn't react to the power button. I found it left in my old apartment after the tenants have left it along with other useless things and mess. The board itself looks to be a decent model, so it would be pity to throw it away to e-waste. Your channel fan at Garrus, I think that is called. So thank you very much for sending the board in and also having some unusual box filler. Thank you very much for that. So, after having removed the unusual box filler, let's get a good look at this actual mainboard then. So, here we have the board, a B550 Aorus Elite V2. So, I can already see he stripped off all of the heatsinks in order for this to be shipped, probably a little bit cheaper. So, nothing on the PCH, nothing on the VRM, which isn't a problem. We got the information that it doesn't react to the power button. So one of the most interesting things would be to check the 5 VSB, if that is shorted, the 3 VSB, and to see if the 12 volts from the CPU has any problems. So, also one of the most obvious things that it could also be is knocked off components. That happens very often. And also being a dead BIOS can actually lead to not reacting to the power button as well. But let's first go for some resistance readings now. So let's see now. We go to the 24-pin connector. Let's make our first few measurements. We take a good ground with our black probe. Then 3.3 volts. That seemed like kilo ohms and rising. Let me probe that better. Yep, kilo ohms and rising. The top left one, left row, fourth from the top left is 5 VSB. This is very interesting for us. Also kilo ohms, that is good. Then 5 volts, the second one from the top. High resistance, 12 volts, top right. 14 k ohms. Okay, if my camera would focus a little bit better. So, 12 volts CPU. Let's see for its resistance. And we have high resistance. Then we go from the top notch, because that is the 12 volts coming in. We're going to take from this, and we can probe the inductors from the top side. Let's see. And we have high kilo ohms. That means 12 volts is also not shorted into our CPU phase. So next we go to one of the PCIe slots. We take a ground. If we go from this notch, and the first pin to the left is 3 VSB, which has also high kilo ohms. So nothing is shorted. So big question now is for other standby voltages. For AM4 we need 1.8 volts standby. We need VDDP 0.9 volts, 0.95 volts, 3 VSB, 5 volt dual. We need, I think VPP needs to be there, the 2.5 volts for the RAM in order to start up. Not too sure on that one, that sometimes is different. Then also the voltage for the ITE chip, which is most of the time also a 3.3 volt regulator. And yeah, this should be about what we need. But in order to check that out, we will need to put a processor in here and get the passive power consumption and then look for some voltages. So let's go to put in a 30, let's go with the 3000G. So we have our 12 volts to 24 pin adapter here. I get asked about that very much. It's just from AliExpress. It's linked in my video description under that name. And then we have our tool for measuring current and voltage. We get that right there as well, the display. So let's now actually see for the passive power consumption. So plugging this thing in, and let's press the passive power consumption. We have around 100 milliamps, which I would say is a good reading. So there's nothing shorted in passive mode. So let's see for some voltages. We can go again to the PCIe slot and measure the 3.3 volts, which is there, as you can see. Then let's see for some coils that are around here. For example, right here, we can see 3 coils. One is probably VPP somewhere here, which should be like 2.5 volts, but it might not be present in standby. Yeah, none of these are present in standby. And this is also not present. So the big question is one of these VDDP or 1.8 volts that should be present? It's kind of hard to know that. Let's see if I can see a 5-volt dual, for example, here, but I cannot see. Oh, there it is, 5-volt dual, okay. Let's see again, maybe my probing was bad. But yeah, I cannot see 1.8 volts or 0.9 volts. There's also the BIOS chip that should have the 1.8 volts on it. We can check that as well. It should be one of the corner pins. Most of the time it's the last one. So the one in the opposite corner of the first pin. And it seems like we have 0 on there, which would mean that probably our 1.8 volts is missing, which would lead me into that area where we have been before, right here. So let's check if the power button even has voltage. So we are going to go on the power button pin. The power button's pin seems to have 5 volts. That might be normal. Let's see. Pressing the power button. No reaction. Yeah, just like he said. If we're shorting these 2 pins, there's no reaction. Okay, well done. I would say we should have a better look into this area right here in order to see if there's anything broken there that we can see already, and figure out what of this should be 0.9 volts maybe, and what should be 1.8 volts, and we might also have a look around the BIOS chip then. So let's turn on the microscope. So there's our microscope view. Let's have a good look here. So I cannot see anything knocked off so far. So no obvious signs of like physical damage around here. Let's see here. This is around the FCH. This should also generate, I think, 2.5 volts in standby. But this looks also fine. This might be either the VDDQ or like the VTT, which is 0.65 volts, but it also all looks fine. No, the VDDQ is up here because we have these dedicated MOSFETs there, yeah. Let's see, this is the PWM controller where we are right here. But all of this also looks fine. Nothing broken here. Let's go around the CPU socket then. All of these look fine. The crystal oscillator. Another crystal oscillator. Some more passive components. Everything looks good here. And we are moving closer to the BIOS, which will be interesting. If there's anything close to there. So let's see for the BIOS chip here. It all looks very fine. This is the chip for the BIOS flashbacking. And it also looks good. Let's have a good look around the SIO then. Where the SIO is responsible for handling all of the standby power. And this is its dedicated power supply right here. We can check if that is running. We need to turn this thing on again. Have the passive power on. As you can see, 100 milliamps. And if we check then this multiple pin device, we check right there, 0.8 volts. Okay, this might be the feedback then, and this 3.3 volts. Yeah. So the voltage for the SIO is definitely also there. So yeah, so far so good. Everything looks very fine here. And this is probably USB-C controller that we can see because there's the port for USB-C. So the top side didn't have anything special for us. Let's have a good look at the back side if we can find anything. So this backside also has very few components. And this is behind the VRM right now. And these look to be very fine. There's only mostly just capacitors and a few resistors here for each phase. But all of this looks fine. This is the back of the CPU. And also nothing special here. And this is the back of the FCH. And yet again, nothing to see. So this board looks fairly clean, to be honest. So no damage, nothing obvious here. So it will be an interesting problem. And I'm pretty sure our problem will be around this circuitry right here, where we are supposed to have like the 1.8 volts and the VDDP. So let's then try to get a board view for this and figure out what kind of voltages are supposed to be here and see why they are not running. So here we are on our board view. Let's now see. I want to see where these voltages are or what these are. VDDP, yeah. So this is a VDDP phase that has high side, low side MOSFET and has this as a controller. Okay, and then the next to it is VDD 1.8 volts. So these two voltages are probably why we are not running. And the big question is which of them should come first now. So let's have a good look at the 1.8 volt phase. This is just a buck converter, an RT8068, which might be our problem. I think this is one of those controllers that always fails. Let me check. No, the one that always fails is an RT8065. And this is an RT8068. But I've had these fail as well because I do have these in stock. So let's see. We will see for its enable signal. So you can see VDD 1.8 enable, and we want to see when this needs to be enabled. So it's coming from an 8.2k ohm resistor, which means 5 volt dual needs to go in there, because this resistor right here is what's called a pull-up resistor, an 8.2 pull-up resistor that pulls this line up to 5 volt dual. But there's one more thing. There's a transistor right here. This is an N-channel MOSFET. It has on its output, it has the same voltage that has been drawn up to the 5 volt dual. And this is a switch. This switch is being used to turn off this enable signal. And to activate the switch, you need voltage on the gate voltage, on pin 2. So if you have voltage here, it connects this pin, it switches this pin to this pin 1, which is ground, which means the enable signal that comes from this resistor gets pulled through this pin to that pin, because this has voltage, meaning it disables our buck converter. So all that this does is a switch to turn it off and on. And now we need to find out, is this switch turned on or off? So we could now either chase already where these are coming from when it is told to switch on, or we could, let's just check for now if this actually is enabled or not. So let's actually see that in person now. We have our passive power consumption. And now we can see this resistor right here. This should have 5 volt dual on one side, which it has. And on the other side has 5 volts. That means this is not enabled. Yep. Because this has no voltage. This switch is turned off. Which means that and that are isolated. Because this is ground and this is our enable signal. That means that is not connected to there because we have no voltage here. So we don't have to follow any of the other paths. That means This now follows this trace up here, up there, and somewhere into here. At some point, this is the enable signal. Let me see. This should be this one there, and it goes probably into this bottom left one. Is this 5 volts? Yeah, there's the 5-volt dual in that regulator. So this regulator gets enabled. So the big question is, why doesn't it output then? So we only see 0.067. And that is basically not a voltage. It does not get hot. So let's then see where the power should be coming in from, because this is a DC to DC buck converter. This thing has a high side and a low side MOSFET integrated in it, just like these dedicated ones are, just that this one has everything in itself, but in a smaller package and can deliver less amps. And what it does, it takes a higher voltage and steps it down to a lower voltage. And let's see what voltage does it have on its input side. So let's see. Most of the time you can see voltages by big capacitors that are close to it. But so far I cannot see any voltage anywhere as an input, which might be our problem. Let's see, often you need big traces like these ones here in order to have its input. And I cannot see any voltage on this side. Because very often it's also the topology that you have one side to come in and one side to go out. In this case, it's these three at the top that are the output that go into here, and probably these three as an input. And our input seems to be low. So we don't have any voltage on our input. So let's see what this input is supposed to be right here. So let's see. This input signal is the enable signal, just like we saw it at the bottom right here. Then these are our outputs, like we've seen here. Let's see, what is this? This is the power grid. This is the signal that gets pulled high if this chip if it's activated and its output is good. So let's see. Pin 6 is feedback, that is for setting the right voltage. Pin 7 is not connected. Pin 8, 9, and 10 is V in. So this is its input voltage. Let's see, where is this all connected to? We have these three connected here. Then let's see. This is a capacitor. You can see this by 1U at the top. It's a little bit small, but yeah. Then we have another 10U right here. This is also a capacitor. We have a Zener diode that acts as a protection. If there's any over voltage at this point, this Zener diode takes that voltage to ground. So if the normal voltage, let's say 5 volts, is applied here, this diode does not lead any current to ground. But if there's an over voltage, let's say for example 12 volts, it would get conductive and lead all of the 12 volts down to ground in order to protect the rest of the circuitry. Let's see, what else do we have then here? We have this thing. This is a 0 ohm resistor. This looks like a 0 ohm resistor. But this is, I think, not fitted. Let me quickly see on the board. Yeah, this is not fitted on the board, but this is connected to 3.3 volts, which is the active voltage of the 24 pin. So this could only turn on as soon as we have a reaction to the power supply. Is this all then? Because that means this voltage only can run as soon as we have the power supply actually turning on. So this 1.8 volts that we have here is actually only an active state. So this is actually not the 1.8 volts that we are searching for. We are searching for the 1.8 volts that is present in standby. But that is very weird that it is like that, because the BIOS chip also gets its voltage via that. And I would have expected that this 1.8 volts is present as soon as you switch on the board so that it is present in standby? That's a big question now. But this is only VCC3. This is not supposed to be here. So let's then see if we have a 1.8 volt rail somewhere here on this board that is for standby. But no, there's only this one. Okay, interesting. So that is not like how I would have expected it. I would thought that we would need this in standby mode, but it appears not to be. Probably the same one is true for the VDDP then. Let's check. This controller is not a buck converter, but this is a PWM driver because it drives a single phase. It drives dedicated MOSFETs. So it also needs a input and an enable. And that enable is being put out also by VCC3, most likely. And the power good of this chip. Okay, so that means the VDDP can only run if the 1.8 volts is present. And we know that the 1.8 volts shouldn't be present. That is very interesting to know. Let's see then. We have VPP, the VPP phase right here. I want to check if that is supposed to run in standby or not. So this is this is the same controller like here. So let's check for its enable signal again. The enable signal just connects to 5 volt dual and probably nothing else. No, there's also a MOSFET to turn this off as well. So 5 volt dual should already turn this on. And now the question is, what is its input voltage? This looks like the very same configuration like we had before with the Zener diode to protect it and 2 capacitors. And let's then see. This is connected to the 5 volt dual. So that means we are supposed to have 5 volt dual here as an input and have an enable signal here for the 5 volt dual in order to have VPP. So for this one, I am suspecting we should have VPP voltage actually here, because the input comes from 5 volt dual and we know 5 volt dual is running, just like the enable signal to turn this chip on is also being dedicated to 5 volt dual through a pull-up resistor right here. But there's also this switch, yet again, that we've seen, like we've seen it before, that can turn this off. So if we have voltage at pin 2, it switches pin 1 to 3, activates the switch and pulls it low to ground. And we will have to check if that is actually the case now. So let's go back to the board. So right now we are back at the board. Let's see right here. We have the buck controller, and the enable signal is supposed to be on this resistor right here, which has 5 volt dual, and its output is low. So this output is probably shorted to ground. Let's see if I can measure it in circuit. That looks like low resistance. Let's go in a low range. And there's 5 ohms. Why is there 5 ohms? Because the MOSFET is activated. Let's see for that MOSFET. So we're talking about this MOSFET right here. If we have voltage right there, it connects that to that. So it switches it on, which means we have voltage here. We have to have voltage on this point. Yeah, 5 volts, because it's pulling that to ground. So the question is, why do we have voltage there? So this we can see connects to here and there and there and there. So this is connected to 2 more MOSFETs right here. So this is also a gate that is being powered right here, connecting these to each other. So I would more expect that we have to see at this one why this one has voltage. So let's see without the board view, just for a little bit to have for the fun of it. This looks like this should have 5 VSB on it. This has 5 VSB on it. And to this side right here has 5 VSB on it. So that probably means we need to find out why this doesn't have voltage. So this probably should carry voltage in order to short this one to there. Because remember, this is the switch. If you have voltage on this pin, the gate, it switches that pin to ground. It connects these two. And what we currently have, we have 5 volts here. But we don't want this 5 volts here. Because this 5 volts turns on this switch, which then pulls low our 5 volts from the enable signal for the buck converter. So what we need to find out is why is this not active? Why is this not being switched on right here? That it pulls that to ground, which pulls that to ground, which pulls these gates to ground, which then doesn't pull this anymore to ground. So let's find out where this is supposed to connect to. So we can see that this now connects to this resistor. Let's see what does this resistor have on it. We have no voltage on this side. And we have no voltage on this side. Okay, so the big question is, why is there no voltage on this pad right here? And why is there no voltage there? Because we need voltage on here. So for this, we now cannot see it anymore on the board actually where all of this is coming from. So we need to switch to the board view. So once more in the board view, let's confirm what I have seen. So this is our gate right now, this pin 2, and it also connects to this pin 2, which is just a gate. Let's see, it also connects to this capacitor, which is unimportant, another capacitor, and a 8.2 carry ohm resistor. Exactly like we've seen it, we see 5 volts on here, and we see 0 volts right here. We see the 5 volts right here. So this is the 5 VSB, it's coming from the ATX24 pin, goes through that pull-up resistor, and ends up here. And we now want this to connect to ground, to pull it low. So this switch needs to be activated, but it's not. And the question is, why is this point not active? So we want voltage on this gate. And let's see right here. This right here is being fed by sleep state 5. So the sleep state 5 feeds this resistor, which is often a 3.3 volts, which then would lead this to have low resistance. So because the sleep state 5 has 3.3 volts, the 3.3 volts goes through this pull-up resistor and then pulls this gate high, which then would connect our switcher, which is what we want. Let's see what else do we have here. This is just another capacitor and yet another transistor. In this case, oh no, this is not a transistor. This is actually a diode. D49, BAT54A, this is called. So this has voltage here and should pass it to there. If I'm not mistaken, most probably. It could be the other way around. But the big question is now, are we missing this sleep state 5? Or are we missing the voltage from this diode right here? Let's quickly, this is also just from another diode down here. Interesting. Okay, where's this also connected? Oh, there's another resistor right here that is connected to the 3-volt dual. So there's more. So there's probably the 3-volt dual coming into this, going to there, and then enabling it, if not the S5. So the big question is the voltage that we're missing the S5 voltage that is coming from here? Or is it actually the 3-volt dual coming from this 1k ohm resistor right here? That is very interesting. Let's have a look at this resistor then for the 3-volt dual. So right here, let's turn the board is still on. Let's see if we have 3-volt dual on this resistor right here. And we have 3-volt dual there, but we do not have it here. Although we do have it. Okay. So the 3-volt dual is definitely present. Let's then look back to the transistors from before. So let's see then right here. This is supposed to be the S5, and we want voltage here. But this dial doesn't carry any voltage, just like there. And this is the diode that we've seen that should carry 3-volt dual right there, I think. Yeah, it does. And the question is now, does it need to lead to here? And it seems to not do that. Let's check the other one below it for that the exact same thing. So it should it has voltage here. Does it have voltage there? It also does not have voltage there. Okay, so the big question is, should it... It's probably supposed to go from there to there. Let's check if we have maybe low resistance at these points. So let's check right here. We do not have a low resistance there. And we also do not have a low resistance there. Let's check the S5 right here. And this has lower resistance, but no low resistance. And this point also doesn't have low resistance. Let's check the actual S5 then. It has 50 ohms. So I'm kind of expecting that it's probably this signal that we are missing right now. That we need this sleep state signal. Let's see. What sometimes helps is to fit a different CPU. To fit a different CPU. Let's take a 3100 and put it into here. So we have a 3100 in here. We have a little bit higher power consumption than before. And let's see now if we now have sleep state S5 at that resistor right here. And we still do not have that. Okay, so that it is not connected to that, to the CPU. Let's see if the resistance is smaller though than we had before, or a different one. And it's pretty much the same. Okay, let's then try to trace where that S5 is supposed to come from. So we have the sleep state S5 right here. Let's see where that is supposed to come from. We have a 22 ohm resistor that goes to the CPU socket also. SLP S5 LSL. Okay, let's see, where else do we come from? This is not fitted. This is supposed to be a 0 ohm resistor. Let's see, there's a 100k ohm resistor to ground. This 1k is also not fitted. And this is a capacitor. And then we also only have the SIO left. Interesting. So the SIO is supposed to give out the S5 signal then probably, which is why nothing is working currently. We can try to bridge that, insert our own S5 signal right here, and see if that actually does anything already. I would be very interested if, like, why does this SIO not give out the voltage? There could be many different reasons why. And one of the reasons could be that the BIOS is faulty, because the SIO needs the BIOS to work in order to function properly. But let's first insert the 3.3 volts into the SLPS5 here ourselves and see how the behavior of the board changes. So we now have voltage, and now I have these tweezers with 3.3 volts, and we're going to be attaching them right there. And let's see, we have more power consumption, which means that the other voltages are probably now running. Let me see here. Let's test if our VPP is running. And our VPP is now running. Let's see for our 1.8 volts. Yeah, the 1.8 volts and the 2.5, the 1.8 and the 0.9 is not running because they need the power supply to actually run. But let's see if we have a reaction to the power button. We will only see that if from the power consumption. So have a good look. No reaction still to the power button. Okay. So there's probably still the SIO having a problem here. But what we can also try is to short the PS on. Let's see about that. 900 milliamps. So that also isn't running. So it isn't only a problem with our power button reaching, but we will have to find out why our S5 is not running currently, which it should be. So in order to make sure that our SIO is working properly, I want to flush our BIOS, because that can definitely be a problem. So right here we can see our Windbound chip, the main BIOS right here. This is a 1.8 volt chip. We are going to desolder this chip, and we're going to put it onto a programmer and an adapter board. So let's prepare it by applying some flux around it. So keep in mind the orientation that we have right here with the dot at the top left, just like that. We're also going to be positioning it on our programmer. So because this has a big ground pad beneath it, there's no reason to put like leaded solder on it, because the ground pad under it has to be soldered anyways. So what we are going to do, we get a big nozzle. I have it set to 450 degrees, and we're going to slowly heat this up. First a little bit the area, and then we are going to get closer and try to heat it up directly. So now I'm going to go and heat it up directly and try to remove it. So the chip actually does not have a ground pad under it, so putting leaded solder on here would have actually made this quicker and easier on the board. So let's put leaded solder onto here, just to have it on there for the next time we're going to be soldering on the chip again, to have this easier to solder here. So now leaded solder is on there, so we lowered the melting point of that, and the chip is on a programmer right there at the top. Right there, you can see it. And let's then go to the PC and program this. So now we are on our BIOS programming software, and I've selected 1.8 volts, and after reading the identification, it found our chip. What we're going to do now, we're going to read the buffer to memory now. So let's see, this is the red dot BIOS. The content actually looks very fine here. We're going to save that as a backup. And now we are on the manufacturer's website, B550 Aorus Elite V2 from Gigabyte. We're going to search for BIOSes, and we're just going to take the latest BIOS here. And after having it unzipped, the file is here, and we can see that the file size is the same as the one that we pulled off of here. So let's go back to the programmer. Let's open up that file. And the content looks very similar. So this might not be the cause of our problem, but we're going to program this anyway. So let it erase right now and program. So, and every second now the chip is actually ready, is finished flushing. And let's now remove it and put it back onto the board, even though I don't think that this will solve our issue here. And with that, the BIOS chip is back on the board. Let me clean this up now. And now our chip is beautifully soldered in here. Let's now try to turn this on once more, but I don't think it did any change. So let's have a good look right now for the passive power consumption. And we do have 110 milliamps. Let's see for the press of the power button, and still nothing. Yeah, like I expected, that didn't change anything. We also do not have our 2.5 volts now. So after looking around the board a little bit more, I finally found the 1.8 volts that I was talking about. There's a VDD 1.8 S5 here. So there is a 1.8 volts standby rail. And that is supposed to come from this right here. And yeah, we need to check if that is present. So we're looking at this left regulator right here. Let's see if on its output it has actually 1.8 volts right there. And it does. That is good to see. So the 1.8 volts standby is there. And then there's a signal called RSM RST that is supposed to be a reset signal for the SIO, I think it is. And that is supposed to be somewhere here, which is supposed to be on this fourth resistor right there. So right here we have 1.8 volts and the other side is supposed to have 1.8 volts, and we have that. So the RSM RST isn't our problem actually here. Interesting. So let me do some further research what kind of signals we also can check here. So it's quite some time later and I cannot believe what has actually worked here. You can see these two crystals. These two are the same crystal oscillator, 32.76K or something that they are called. And I didn't have any oscillation on any of them. You can already see a higher passive power consumption where I cannot, under me, right there. You can see the 12 volts right here, and further down, you can see 130 milliamps. And if we now have a look at my oscilloscope, it's a bad setup, I know, but it's all I have. If we now probe here, we can see the waveform. And also there's another waveform. This is, it should be probably that one, but I don't have the hands to currently position that properly. But if we look at this one right here, we have an oscillation now. And now the big question is, what I did, I changed these around. I changed these two. And my question is now, is this one faulty or not? Because what I definitely didn't have this oscillation right here. And this oscillation means that the CPU isn't working because it needs this oscillation in order to work properly. And this wasn't present. And I need to find out what this one is for, because most probably this one is actually broken and not oscillating properly. So I get the oscillation on the pin that is further away from the A. So it should be this pin right here where I get an actual oscillation on this one. Let me see if I can adjust this, if I just need to do my scale better. So there's something on this crystal, but I cannot get a good signal off of it. So we will have to find out what that is for, but let's have a look at the board now. So we can now see we have way higher power consumption. And if we now press the power button, we actually have a reaction to it. The post screen is enabled. We should also see that. We now have LEDs here. We don't have LEDs at the back yet. But look at the power consumption. This board is booting up. I cannot believe this. There's no indication LEDs anywhere of what where we are currently with the post. But we should probably get a picture every second now. And there's the post screen. I cannot believe this. It is actually working. We had either the soldering was bad on the crystal, or it's the crystal that I changed out that is bad. I need to find out what the other crystal is for and to see if that now works, in order to see if that one crystal was actually faulty or not. Because there's the BIOS. Cannot believe this, that it had to do with the crystal that was on there for the CPU. Let's together see in the board view what that crystal is for. So you can see where I was poking around. We have these two crystals, AX1 and ORTCX1. And these two I changed around. These two are the exact same crystal. And from this crystal, the signal is going into the CPU. Just like here, this one. And I know for a fact that these two pins, with these don't have oscillation, the AM4 does not power on. You don't have a reaction to the power button. I know that because I had a CPU that I tried to repair on this channel that had one of these two parts missing. And the result of it was that the board wasn't turning on with the CPU anymore. So it must be this one that was faulty that is now here. The big question now is, this one goes into this chip. This chip takes these two as an input, ground SMB clock and data. Then it has RTC VDD3, so supply voltage, and then this outgoing voltage that is SAS CLK Wi-Fi. And where does this go? And this goes to a potential Wi-Fi card that you could put on here. An M.2 Wi-Fi card. So probably the crystal is actually broken that I put onto there. But I cannot test that because there's no Wi-Fi card and I don't have a Wi-Fi card to put on there to test it. So if anything, if that crystal was actually broken and not the soldering of it, the M.2 Wi-Fi won't work anymore. And let's see at the board, because I just saw something. This thing doesn't even have it does not have the connector. The connector is not soldered on here. There are components, but the connector is not in here. Why does that chip then exist? If like the Wi-Fi thing isn't even there. So if anyone can educate me what this thing does, because if there's SMB data and clock, that means it can talk on the SMB bus. The SMB bus is a big bus between the CPU, RAM, and other peripherals on the board where they communicate with each other, kind of like I2C, but different. But there's nothing more. There's only the oscillation going into there. There's the communication between SMB bus and clock and data. There's the supply voltage for that chip, and then there's the signal for the Wi-Fi. I cannot believe that. Is it really that this crystal was broken that was here, and there was just another one here that isn't used and that actually worked? It might have been the soldering. I do not know. I only know that after having changed these two out, it now works. What a stupid thing to have happened to this board. So there now is a 4100 in here with an M.2 SSD in order to boot Windows. There's also a GPU in here now that we can test the first PCIe slot. I've put RAM in each of these slots in all 4 DIMMs so that we can test that all 4 are being recognized as well. And yeah, what can I say to this? I've never seen a dead crystal before. Pretty surely. Like I have had so many motherboards. Like this channel exists over 2 years now, and I've uploaded a video every week, and before YouTube I've already been repairing motherboards, and in all of that time I've never encountered a dead crystal. Maybe I should check on some few more boards that I have that are laying at my place for a longer time now. That there might be a dead crystal there actually. And that was the problem all along on other boards as well, because I have a few AM4 boards that don't react to the power button, where I don't get anything, and it might be the crystal for all I know. But yeah, I cannot believe that this has actually repaired this board. And please, if you know anything on what that extra crystal oscillator is for, that is only connected to that chip and the SMB bus and the Wi-Fi card. If you know what that is for, please let me know. Because I don't see the reason for that to be populated if the Wi-Fi isn't connected here, like here. Like, I don't know if they forgot to take it off of there, because that was my only saving grace here, why I even attempted that, because I saw, okay, there's 2 oscillators that are the same. Just let me quickly swap them around and see if that does anything, without expecting it to actually make a difference on this board, to be very honest. But yeah, you can see the post screen right there. It's going into Windows. And I even have Ethernet. I can already see by the indication LEDs. So this board is definitely working. I also have have all of the USB devices that I connect to here. So yeah, I'm properly confused, but also happy that I was able to fix this board for this viewer. But that's something new I learned today, a new experience gained, something that I will definitely be checking in the future to have that oscillation for AM4 in order to have it start up. And so the big thing here is we didn't have S5 state. The S5 state is being put out by the CPU pretty surely. And I thought that there wouldn't be a problem with the CPU because you did have some voltages that only rose with the CPU and the passive power consumption went up when I put the CPU into there. I also checked the CPU socket with the DDR tester that actually also was fine, and it indeed was fine. So I wouldn't have expected that it's actually a fault coming from the CPU side. I thought there would be a fault with the SIO side of things. And I kept checking a lot of things around there, but obviously it wasn't the problem. So yeah, one more thing to learn, one more thing to check. Wouldn't have expected this to be the fault, but very happy that this is done now. Like, I wouldn't tell anyone to check the crystal pretty honestly, because in all of those years, it never has happened to me before. But, well, something yet again that I need to pay more attention to and that I have learned now. Very well then. I hope you enjoyed this video. All of my tools are linked in the video description. If you want to get one of these self-made current testers that I make, they are linked in my video description. You need to email me about them. I don't have a good link yet to where you can buy them, but yeah, I do that via email. And all of the other tools that you see are linked in my video description. If not, just leave a comment down below and ask me about them. And yeah, this was Mainboard Medic. Thank you very much for watching, and goodbye.